Sharon, shall we start? Hello. Sharon, are you there?
Yeah, please, sir. Please start, sir. Now you can start. Yeah, please.
Great. Okay. Welcome everybody. Sorry for the slight delay in the starting the class. Happy Independence Day to all Indians who are here. Basically, this is a very short refresher presentation on why children should be encouraged to study mathematics and especially Vedic mathematics. I just have 20 slides, and I think in about 30 minutes, I'll go through the entire slides and then I'll take your questions. Okay, the first thing is why study mathematics, and especially why we should encourage children to study Vedic mathematics. First and foremost is that maths is the most perfect of all the sciences. There's no ambiguity. 1 plus 1 is always equal to 2. 1 into 1 is always equal to 1. 1 minus 1 is always equal to 0. And 1 divided by 1 it's always been and will remain equal to 1. Maths has huge application in the domain of engineering, physics, chemistry, biostatistics, commerce, and finance as well. Vedic maths, apart from enhancing numeracy, can be applied to virtually every school maths concept such as LCM HCF, simultaneous equations, quadratic equations, trigonometry, compound trigonometric angles like sine A plus B, cos A plus B, integral calculus, etc. In fact, Charan is a big expert on the application of Vedic mathematics. Moving forward, the most often question is, what is the difference between maths and arithmetic? Anybody who can answer this on chat, what exactly does the word maths mean? Is everybody able to listen to me carefully?
The voice is very low.
Sorry, am I clear? Am I loud enough?
Yes, now it's fine.
Sorry?
Now it's fine.
Okay, great. Okay. So anybody can type
sorry,
answer and tell me what exactly does the word maths mean. We always
hello?
we studying
Hello,
math.
can you hear me?
Sorry?
I am leaving the meeting because there's an urgent
Can
thing
you
that I
type
need
that,
to
please, ma'am? Because I can't hear you very clearly. Anybody who can tell me what the meaning of the word maths is. Anyway, I'll remove the suspense. The word maths, literally, if you look at the etymology of the word maths, it means to learn. And a polymath is a very learned person, like the Swamiji. Sweetie, no, it's not logic. So the word maths means to learn. And a poly obviously means multiple and many. And Swamiji, who invented or rather rediscovered the concept of Vedic mathematics, was actually a polymath. He was learned in Sanskrit, literature, arts, astronomy, Vedic maths, of course. And if anybody can tell me what's the difference between mathematics and arithmetic? Arithmetic is basically the branch of mathematics. So it's a subset of mathematics which deals with the properties and manipulation of numbers. So when we are talking about school mathematics, what exactly we did, in school, like, we learned 1, 2, 3, then we learned how to add, then we learned how to subtract. That branch of mathematics is called arithmetic. India's contribution to maths is huge. We Indians invented zero and its applications. In fact, Einstein once remarked that, without Indians having invented zero, no physics would have been possible, and his theory of relativity and all other mathematical and scientific contributions in the modern age would not have been possible. And the mention about the number zero is mentioned in none of our scriptures, but it's typically mentioned only in one temple in India. It's the Chaturbhuj Mandir, and it's inside the Gwalior Fort. So there you can actually find the mention of the number 0 and its application. And the Chaturbhuj Mandir is actually dedicated to Lord Ganesha, who was also known for his profound wisdom. Buddhayana found the Pythagoras theorem. The Pythagoras theorem, Buddhayan's description about the Pythagoras theorem precedes Pythagoras by at least 500 years. So we Indians were like, well ahead of the Western world, especially of the Greek Hellenistic world. Most calculus concepts were founded in India. And in fact, when you do integration, then you have two functions. For example, sine of x multiplied by e to the power x dx. This concept is called integration by parts. And surprisingly, a lot of Western mathematicians, including Leibniz and Newton, they have said that integration by parts is the Hindu system of integration. And if you read Ken Williams' book on Vedic mathematics, he has an exclusive chapter of application of Vedic mathematics to school mathematics. Ken Williams is a very big Vedic maths expert. So you can actually check that you construct a table, and one side you differentiate, the other side you just integrate the functions, and very quickly you'll be able to find out the answer. Binomial theorem and Pascal's triangle were known to Indians. So basically the binomial theorem goes somewhat like this: x plus y raised to the power n, where x and y are the two polynomials over here. And in the modern world, it's nc0, x to the power n, y to the power 0. And it goes on to ncn, x to the power 0 and y to the power n. We use the binomial theorem in the world of Vedic mathematics. For example, we have to cube 12 cube. So it's very easy to actually cube it. I mean, over here I'm just not putting on this particular function because combinatorics were not invented by Indians. Computation combinations were not invented by Indians. This is a gift of the Western world. And then you have 3a squared b and goes on till 4 terms. And this can be actually split up into a squared b plus 2a squared b. So all this, the binomial theorem and your Pascal's triangle, your Pascal's triangle goes somewhat like this. The coefficients, first you have 1, then you have 1, 2, 1, then you have 1, 3, 3, 1, and so on and so forth. Again, x plus y raised to the power n. All this was known to Indians, and we made vital contributions to the world of mathematics as such. I'll very briefly talk about maths symbology. Maths symbology basically originated about, say, 400 years back. It's began, and we have a lot of symbols in mathematics. Now, in entire schooling, we were never taught what the plus sign stands for. The plus sign stands for St. Andrew's cross. We were never taught about what the middle hyphen is. The minus sign, the subtraction sign is the middle hyphen. The multiplication sign is actually called a saltire. So some of you who are trainers and who have interest in maths and biology, this will come in very useful. The division sign is called an obolus, and the plural is obuli. Same thing as abacus becomes when plurals of abacus. It's not abacuses, but it's abaci. So similarly, this comes from the English language. The letter U is actually becomes double I over here. And in the world of computing, the division sign is this. Now, this is not exactly called a forward slash, but it's called a solidus, and it's also known as a virgule. So you don't have this symbol is not there on your PC, but you have this symbol for the division. It took 250 years for these math symbols to arrive in the world of mathematics. It was not something which came just in a flash or something. It took about mathematicians 250 years to realize that it started with the addition, and then subtraction came in, then multiplication. And maths also uses a lot of English typographical elements, like the factorial sign is actually the exclamation mark. It's called the factorial. Less than, greater than sign in school, we were never taught and we never bothered. In fact, in school, in the French language, for example, they don't use double quotes. They use the less than and greater than sign. And these quotes are actually called chevrons. Ramesh said this: I am a maths teacher. So the French people, instead of putting double quotes, which the English people and the Americans do, they don't use these, they don't use that. They use the less than and the greater than sign. This is, more of, I would say, from an interest perspective. And these quotation marks are actually called, they're written as guillemets, but the correct French pronunciation is guillemots. Then you have symbol for infinity. For example, you have a fraction 2 divided by 7. And since some of you are maths trainers over here, this is actually it's called the fraction bar. And alternatively, in more refined terms, it's also called the vinculum. And vinculum is actually Latin for to tie. So basically, when you put a vinculum over here, you're tying the numerator and the denominator. You have the under root sign. So under root of 144, you put a vinculum over here. Repeating decimals 0.175, 175, you again put a vinculum. This is what it is. Not many teachers do. This is a sign for infinity and it's called a lemniscate. There are multiple symbols in maths. They took some time to evolve. And can anybody tell me, before the equal to sign was invented, what were mathematicians using instead of equal to? And equal to is a very recent innovation in the world of mathematics. What were mathematicians using instead of the equal to sign? And the equal to sign was actually invented by a Welsh mathematician called Robert Ricordi. Interestingly, mathematicians were writing is equal to. For example, in geometry, you must have come across this Latin phrase, QED. So, you don't write out the complete phrase, but you just write QED. What had to be proved has been proven. So instead of the equal to sign, Robert Ricordi, instead of writing is equal to, Robert Ricordi invented the equal to sign. You want me to speak louder? I'm at the maximum volume. Let me just one sec. Let me check my audio settings also. Okay, I've increased the input level now. Okay, am I better now? I've just adjusted the settings. Can somebody just let me know by way of chat? I think my apologies, my input volume was not on the outside. So that's something about maths and biology is very interesting. Quick question. This is mentioned in an NCERT class 5 textbook. Why do we use Z for the set of integers? Can anybody tell me why do we use Z for the set of integers? Any idea?
Yeah, scientist name actually I forgot it.
Sorry?
Scientist name, mathematician.
Sorry, I didn't get you very correctly. Any rough idea? Okay, I'll remove the mystery. Basically, the letter Z is Zahlen in German. And if you notice, I have put 2 dots on top of the letter A. Now, these dots actually come from Germanic and Scandinavian languages, and they're called umlauts. And one application of mathematics is the world of actuarial sciences. So you will have annuity payments written as this, annuity payments written as like this, and annuity payments written as two double dots. So this is like a continuous annuity payment, and this is the one with umlauts. And this is like an annuity which is paid upfront, and this is like a deferred annuity paid at the end of the year. So the word Zahlen is this, A is basically to emphasize, and it means counting in German. So when mathematicians were dedicating the English alphabets, letters A to Z, the letter I was reserved for the set of imaginary numbers. So they came across, they said, okay, Zahlen is counting. And there are several words in the German language which end with the word Zahl. So, like if you have inferior count of, let's say, army numbers, or if somebody's count is like less than somebody else's, I think in German it's called a Zahl. And it's Zahl, something like this. So that's how, you get a lot of words and things. And this is mentioned, in an NCERT class 5 textbook. I've been teaching some kids. So you'll find this written in the NCERT class 5 textbook. Moving forward, 0, the letter O is for degrees, but C is for radians. Why? And we know that pi radians is equal to 180 degrees. Have you ever bothered to find out why do we have this 0 for degrees, and why do we have this letter C, this one over here, which are written? This is again not mentioned in NCERT textbooks. I have not seen it anywhere. R.D. Sharma's class 10th or I think 11, no, sorry, class 11 textbook, this one mentions that, this is the class 11 textbook of R.D. Sharma mentions this. Anybody, all of you are, I'm sure most of you have studied mathematics till class 12. So why do we use the letter C and why do we use the letter O over here for degrees? I'll remove the suspense very quickly because I'm not, expecting any answer. And the answer is very simple. Now, what exactly is a radian? Supposing I have a radii, two radii over here, one unit, and it subtends an arc which is also of 1 unit length. Then we say that the angle which is subtended at the center by these two radii, this radii and this radii, is equal to 1 rad. And if you look at it carefully, what exactly, this is a circle which represents a letter O. So we have degrees for that. Now, if I slice off this particular portion, and I just consider this particular portion, does it not resemble the letter C, the arc of the circle? That is why we use the letter C to represent radians. Small thing, but it's like part of maths trivia. But we should open up our minds to, we should be receptive and we should be inquisitive about finding out why this happens. 0 to the power 0, I've asked quite a few people, why is it, what is it equal to? I prepared this Microsoft Excel worksheet yesterday. I started with 1.0, and in the next column, I forgot to mention it over here. What I did was, I did 1 to the power of 1. Then I moved to 0.95, and I tried to compute 0.95 to the power of 0.95. And if you look at this particular second column, second row over here, the answer is 0.952440. The values keep decreasing. From 1, we come down to 0.696845, and then there is an inflection point. So if you plot this graph, the value 1 to the power 1 will be something like this. The value is going down, and then the value starts hitting up again, and it's like when we push to a very fine number, like it's basically 0 to the power 0, it's a kind of a limiting function. We're trying to find out, when we bring it down to 0.005, and then we go further down to 0.00005, and I have computed this to maybe 7-8 decimal places. And in that process, what I've done is I've, basically brought it down to a very low number, which is almost like mimicking 0. So this answer is 1. And mind you, if you use the Casio calculators, if you use the Windows calculator, or if you're taking exams like the GMAT, GRE, and the SAT, definitely not on the SAT, but on the GMAT and the GRE, the answer would be 1. And over here, like I went down to this website called calculator.net/scientific middle calculator.html. And if you notice carefully over here, this is the value. I've done a screenshot over here. Not many textbooks actually teach this concept, but there you are. Problem with maths textbooks, they're very poorly written. Great example is NCERT, textbook class 12, supposed to be used by students pan India. Chapter number 7, volume number 2, integration by parts. There is no mention, not even remotely, of, just one second, what was I saying? Okay, chapter number 7, volume 2, no mention of the IDET rule, integration by parts. R.D. Sharma does mention it, but this is, when you have two functions. Let's say you have a function called sine of x multiplied by e to the power x dx. Which one should be my first function and which one should be my second function? Now, the exponential function is always the second function, because when you differentiate e to the power x, you get an e to the power x. When you integrate e to the power x, you get an e to the power x. So this is kind of a hopeless function. So we use the other functions, the inverse trig, logarithmic, algebraic, and the trig functions as the first functions. Very sad that an institution like NCERT, they've written a textbook and there's no mention of the IDET rule. Maths teachers do not clear fundamentals. This is very, very evident based on my own experience as a math student, and also when I teach maths to other children. Very important concept, a circle is actually a triangle. The area of a circle can actually be found from the area of a triangle. And we all know that the area of a circle is pi r square, and the area of a triangle is half base into height. The area of a triangle actually comes from the area of a square. So this is a square, all sides are equal, x units, x units, x units. I draw a diagonal over here. So this is 90 degrees. This particular triangle, the area would be half base into height. And in this case, it would be half times x squared. But the surprising thing is that the area of virtually every polygon comes from the area of a triangle. And if you remember, there are several ways to find out the area of a triangle. I think the area of an equilateral triangle is √3/4 a square, where a is the side of everything. There are ways to find out. Half base into height is one way to find out. Then there was a very famous Greek mathematician who also, using the semi area, you can find out the area of a triangle. Circle is actually a collection of n contiguous isosceles triangle. If I drop this particular area, I have some area left over here. But if I collapse the radii, I bring both the radii together, the area of this particular triangle would be half into height, which is radius, into a point on the circumference. And then I, add up all these triangles, and then I'll be able to get the area of the triangle. Why logarithms of a negative number is not possible? Now, this is a small chart which I made. This should actually be 10 to the power 0. I'm sorry for the typo. 10 to the power 0 is 1. 10 to the power 1 is 10. 10 to the power 2 is 100. All positive exponents. 0 is neither positive nor negative. 10 to the power minus 1 is 0.1. But what? Negative or positive? Plus 0.1. 10 to the power minus 2 is plus 0.01. And what do we do in the world of logarithms? We find out logs of these numbers, and they're all positive numbers. For example, I'll show you over here. you are finding out log of 100 to the base 10. So which is basically coming from this particular thing. If I were to find out log of, let's say, 0.01 to the base of 10, answer I get is -2. But the log that I'm finding out is of a positive quantity. That is why when you do calculus and you use the ln function, and some textbooks like R.D. Sharma have used, they consist, page after page, erroneously they're saying log of some function, or let's say log of sine of x. This is wrong. In the world of calculus, you don't have log to the base 10. This means log to base 10. This is log to base 2 or binary logs. Log which is used in calculus is ln, which is log to the base e of, let's say, any function. It could be sine of x or anything like that. And for example, another mistake which even I've seen some engineering students also make is, for example, if you're doing calculus and eventually you come across a function like ln of x square, you don't need to put the modulus sign. But let's say you have a function called ln of x, your answer results in an ln of x. Then you put the modulus sign, because you can only compute log for a positive quantity. X square, irrespective, whether it's fractional, whether it's in decimal, whether it's negative or positive, by virtue of square, will always be a positive quantity. So this is, you don't put a modulus sign over there. This is wrong. This is, you only put when you have a function which can result in a negative quantity. X can jolly well have a number like x is equal to -1. So to remove that, to bring about positivity, you put ln of x. It's a very important concept, and sadly, the CBSE curriculum, they don't teach logarithms. ICSE does, but CBSE doesn't. Relationship between LCM and HCF, very easy. LCM into HCF is equal to product of two numbers. Kids in class 4, class 5, they're not aware of this. Componendo Dividendo, again not taught in CBSE, but is taught in ICSE. This is a very vital concept that's also used in calculus. If x by y is equal to a by b, then x plus y divided by x minus y is equal to a plus b divided by a minus b. And in ICSE, the board exams, you typically have a 3-marker or a 4-marker question where you have to do this componendo dividendo process not once but twice. Briefly, I'll explain this. If x by y is equal to a by b, it's given. I add +1 to both sides of the equation. My equation on the left-hand side becomes x by y plus 1 is equal to a by b plus 1. And if I take the lowest common multiple, so this is x plus y divided by y is equal to a plus b divided by b. And this is my equation number 1. Similarly, if I subtract 1 from both sides of the equation, it becomes x minus y divided by y, and then subsequently on the right hand side you have a minus b divided by b. This is my equation number 2. And supposing I were to divide equation 1 by equation 2, this y and y over here will get cancelled off. This b and b will get cancelled off, and I'm left with x plus y divided by x minus y is equal to a plus b divided by a. I encourage all teachers over here to read this British classic textbook on algebra called Hobbes. It's a must. It's a beginner's book, and there is an advanced book. So they're not very expensive. They're about 70 rupees for the beginner's book. The advanced book is about 150. Whatever on Amazon. Very vital concept. Again, not taught in CBSE, but ICSE teaches. Integral calculus concepts not mentioned in any textbook or in any YouTube video. Why do we use the following 3 trigonometric identities in algebraic to trig U substitution? Sine square theta plus cos square theta equal to 1. We use it when we have an integrand of this form. Tan square theta plus 1 equal to secant square theta when we have an integrand of this particular form. And then secant square theta minus 1 is equal to tan square theta. So I'm sorry. When you have an integrand of this particular form. Not mentioned in any textbook. I've seen a lot of classic calculus textbooks. Not mentioned on any YouTube. I've seen Eddie Wu's YouTube videos. I've seen Nancy's YouTube. She's an MIT professor, or rather, I think an MIT graduate. I even once asked Nancy about it. I had never got a reply on her YouTube channel. Similarly, another integral calculus concept not mentioned in any textbook. They just ask you to cram a formula. Why do we do a repetition of a factor under integration by partial fractions? Why? Just because I'm getting a square over here, I could have left this as a divided by x plus 1, and my other factor in the denominator is also a linear function. So I could have left it as x plus 2 whole square. But no, that is no. We do an x plus 2 and then we do a repetition. This is where the power is 2 and this is the, it's a linear power. I leave this to your imagination to answer these questions for me. Okay, this is, you could just look at this slide. I practice these two things, so I just wanted to mention that it's very essential to have these practices. Coming down to Vedic mathematics, brilliant system. School mathematics, children will not be able to do it. This answer is very simple. The right side of the answer would be 7, 3, 1, 2. I hope I'm correct. 2879 Western Maths will tell you to add this positive quantity and then add this particular positive quantity. So you'll get one quantity which is positive. Then they will ask you to add this and add this. You will get another quantity which is a negative quantity. Vedic Maths does away with all this. I'll just give you a quick example using the first set of numbers. So this can be written as bar 1, bar 2, bar 3, bar 4. This is wiped off. 9 minus 4 is a 5, 7 minus 3 is a 4, 8 minus 2 is a 6, 2 minus 1 is a 1, 6. And you can do it for n number of, you can do it for n number of components, negative, positive quantities. Any negative quantity, for example, over here, 1, 2, 3, 4 is all negative. This represents, these vinculums represent negative. Just one. 287 divided by 998. Children will struggle. I've had children struggle. Basically, what Vedic Maths does is it takes the deficit of 998 from its nearest base, 1000, and division is reduced to simple multiplication and addition. You can also convert this into vinculum numbers. The dividend can also be vinculumized. Again, this concept, none of the Vedic Maths textbooks, in fact, Swamiji's textbook is possibly one of the worst Vedic Maths textbooks that I've read in my life. I bought it in the year 1986. I still have my name and the date I purchased it written on it. I've never been able to understand anything. Everybody talks about the divisor being vinculumized. If I can vinculumize a divisor, why can't I vinculumize the dividend? I had a recent discussion about a month back with Charan on this, and then I sent him some slides and he agreed. He said he was possible to do the process. Vedic Maths can typically be learned in 3 hours if you have a good tutor, and it improves your numeracy. I heartily encourage all children and parents to learn this and teach it. Vedic Maths is applicable to almost every school maths concept. Vertically and crosswise sutra can be applied to something like 15 very complicated mathematical concepts. Finally, I will not bore you. And children often say, like, why should we study maths? Why don't we study medicine? Why don't we study art, literature, economics, finance? So there is a field called Actuarial Mathematics, very highly paying field. Typically, jobs in the US are $100,000 for associate. Sadly, India doesn't have too many good actuarial companies, and there are not many actuarial firms operating out of India. But the starting salary is about 6 to 7 lakhs, and they quickly, shoot up into 10 lakhs and more. Very high job stability. No actuary has been fired in the last 40 years. It's even possible to break into actuarial consulting after having 15 years industry experience. what you're seeing these days during the times of COVID is the concept of work from home. So one can actually, you just need an internet connection, you can get some clients from the US and you can start doing actuarial consulting. Contrary to popular myth, the exams are not so tough. The study material is very poorly, very badly written. They do not test on trigonometric functions. For example, they will not test you on what is integral of sin x dx. So they just test you on algebraic functions. So when you come to the islet rule, your inverse trig and trig functions get knocked off. They test you on ln functions, algebraic functions, and your exponential function. So it's basically 3 out of 5, makes life a lot easier. The level of calculus is not at all difficult. I've taken the actual common interest test and cleared it. It's possible to complete the core exams along with graduation. And I've just left a screenshot over here, which is from IFOA UK. So you can go to this particular website which I mentioned over here, and you can find more details. And there are a lot of people who train. So that was it. I can take your questions, and maybe if you have some, you can type them, or you can, possibly speak it out. I think it would be better if